Good morning all and welcome to Next Level Physics, where today our topic is energy conversions within the refrigerator. My name is Professor Doppler E. Fecht, and today we will explore the wonderful universe of energy transformation and how this will relate to everyday life. Henry Smith joins us to discuss how energy can transform into multiple forms to make our home appliances run smoothly. How are we, Henry?
Great, Professor.
So Henry, can you tell us how energy is fundamental to smooth running of daily appliances?
Well, conceptually, it's quite simple, really. Energy has the ability to change forms and therefore perform different tasks within a situation. Thus, energy can similarly pertain to qualities that achieve different purposes within a home appliance.
Fair enough. So today, we will be looking at the refrigerator as an example of a home appliance. But before we move on into further detail, Henry, please explain the law of conservation of energy.
Well, basically, the law of conservation of energy states that energy cannot be created nor destroyed, just transformed from one form to another.
Yes, but how does this relate to a refrigerator?
So, at the beginning, energy is formed at a power station. It is from here that the energy will end up in our home appliance, the refrigerator. As we all know, fossil fuels are our current source of energy. Fossil fuels are burnt and the heat is harnessed to boil water, where the steam is then released to rapidly spin large turbines. Through thermal transmission, these large turbines power a generator where electricity is formed and is finally sent to our homes through power lines you see along the streets.
That about sums it up, Henry. So, as you can see, before even the refrigerator gets involved, energy has transformed itself from potential energy to chemical energy to heat energy to kinetic energy to electrical energy, all within one power station. And this keeps to the law of conservation of energy because the energy is only transferred from the fossil fuels and through the process turned into electricity.
Now that we have established different forms of energy, how is it special in a refrigerator?
Well, like the power station, the refrigerator uses different forms of energy to work. A refrigerator's primary job is to keep objects cool, which requires the fridge to function as a heat absorber. But before that, remember the electricity from the power station? This electricity is sent to a motor at the back of the fridge. In this motor, electrical windings are used to create electromagnetic fields. There, a rotor spins rapidly with the help of magnets to transform the energy to a usable form.
This energy uses certain refrigerants. CFC, or chlorofluorocarbon, is a particular type of element that has the ability to absorb heat energy. However, because of the poor impact on the environment, HFCs are used in modern refrigerators instead. HFC, or tetrafluoromethane, functions the same except that it has a far lesser effect on the environment.
Thanks, Henry, and you're spot on. So recapping, the motor spins from electrical energy, which is then transformed into mechanical energy, to be transferred to chemical energy to pump the CFCs or HFCs around the fridge. The CFCs or HFCs are pulverized in the compressor and thus turned into a high-pressure gas. This gas then travels up some coils and is exposed to the outside air. Because of this, the air outside absorbs the heat in the gas, so it cools down to form a liquid.
You may be wondering, how did it form into a liquid? Well, when a gas is cooled, the particles in it do not move as rapidly, so they come closer together, condensing into a visible liquid form. Ammonia, a detrimental chemical, is drained away from the CFCs and the HFCs, and the remaining liquid enters a series of coils within the fridge. In these coils, the heat that has risen within the refrigerator is absorbed into the cold liquid.
So now that the liquid has absorbed the heat into the fridge, it goes through another set of coils and transforms into a low-pressure gas. It is then reunited with the ammonia, but now it is sent back to the compressor, in which it will continue to repeat this cycle. So let's reflect as Henry draws our path behind us. Electricity provided by the power station sent through electrical wires to the refrigerator transformed into mechanical energy within the motor to create the power needed to work the compressor. This pumps CFCs around the cycle by compressing them into a gas, filling them into a liquid, separating them and exposing them to risen heat in the refrigerator.
Yes, that sums it up, John. It's amazing how energy is able to transform so many times to power what would seem to be a mundane kitchen appliance through the use of complex and structural transformation.
Indeed it is. Thank you all for listening. This is Professor Doppler Effect, joined by Henry Smith, our topic of refrigerators from next level physics.
悲しい夜が僕らを包むけれども僕らまだまだ夢を見ているそれだけで十分さそう十分さ
Henry, can you please explain the law of conversion of energy?
Well, basically, the law of conservation of energy. Fuck around there! I can't see!
Good morning, Earl, and welcome to...
What?
That sums it up. Sorry, start again. I first for doing this paragraph.